not forget to do the important thing. So with this question, let's see, it's out of 8. Ooh, yeah.
Yeah, that's why I said I understand the complexity of it, but like, yeah, no.
Okay, no, the thing is with 8 mark questions, to be honest, right? The idea is that you don't just want to think that you're gonna just do 1, 2 things and then done. No, it's more like, you know, a mini journey where you're gonna do one thing and then another thing and then another thing and then back to the main question. Like it's more like you have to set the question up for yourself. You see, you have to answer like a specific question and then another one and then another one. So that's the big idea. That's the big idea. Let me
Hey.
see here. So it says in the diagram, or rather the diagram represents a model of a still arc. And the fortunate thing is, I mean, there will be, if you want to go through this on the course platform as well later on, because it's there, you can always just do that. It says a diagram of a model arc of a still, not of a model still arc, which is an arc of a circle with center C. So they're just gonna say this is actually the still arc here, this part here. The rest is actually not there. However, if you think of this small part, it is a small part of what would have been like a big circle that has a center C. That's what they're telling us. Then they say here the width AB, right? So there's A going to be here of the arc is 16 centimeters. So it's 16 centimeters, right? So automatically, you know, this is 8 and this side is 8 because that's just how a circle is. It's symmetrical. Now, as long as we can see the center is right in the middle here, we know that if you draw a line here, half is going to be there, half is going to be there. And then they said, and its maximum height OE is 2. Okay, so this is 2. And then it says here, one of the vertical pillars that supports the arc is at point P. So you have a vertical pillar here that's supporting the arc. And they said it here, it is the midpoint of OA. So what we also then know is that this is 4, this is 4. The whole thing is 8, the whole thing is 8, this is 4, this is 4. Now, if it's a vertical pillar, then we know this angle is 90 degrees. It's a line going straight upwards. So all this being said, they said here, supports the arc at point P, the midpoint of OA, and then O is the origin. So the one thing that is actually quite important with this question is that we have a Cartesian plane to like work with. You see, x-axis, y-axis. Now for 8 marks, they're asking us to determine the equation of the circle with center C in this form. So if you can recall from what we mentioned in the beginning, it's an 8-mark question because it's just like you have to take different steps bit by bit to get what you eventually need, you see. So the fortunate thing is, don't worry about this. What you want to worry about is to get it in this easy format first. Because as long as you can get it into this format is easy, because from here you can just multiply out your numbers and then you will end up with something in this format. So this is what you actually want to do first, and then this will follow, you know. So that's one way to keep the equation simple. Don't focus on this, because if you focus on this, you cannot do it like this. You have to do it like this first. Now you doing it like this, it makes your life easy because now you only have 2 objectives. You can already see out of 8 marks, you have 2 objectives, because the rest, they just follow on to that. They just follow on that. So the first thing is we need the center of the circle. Now the fortunate thing that we can already realize is that we have the x value of the center. I'm like, we need an x value and the y value of the center. What we already have is the x value. It's a 0. You see? So because it's this C is aligned with the origin, it's nowhere to the left, it's nowhere to the right. So that's something useful. The next thing that's obviously useful is all these different pieces of information that they gave us. Now, with this kind of a sketch, I mean, like here you need to be very, very free to add whatever you can add. Now, with a circle like this one, it looks like adding a radius may be useful to us. So this is like the radius of our circle. And what we know about this radius of our circle is we don't have it. We have nothing. Now we could work with maybe this side of the sketch, or we could maybe even work with the other side of the sketch. Now, because they mentioned something, on this side of the sketch, the weird thing with this question is it looks like there's only, let's see if there's a B follow-up question here. Since this is A, let's see if there's question B. Well, not in this case, there's just A. So what we can do for ourselves is, for now, we can just worry about getting the radius and the center. So in terms of like a train of thought that a person can follow to try and answer these questions. Firstly, I mean, it's an 8-mark question, so you have plenty time. You have technically 8 times 1.8 minutes, which is, 1.8. So 1.2. 1.2 times 8 is giving you almost 10 minutes, approximately 10 minutes on this question. We'll do this, approximately 10 minutes. This 1.2 comes from the fact that a full paper is usually like out of 150, right? However, you have like 180 minutes since it's like 3 hours. So this is to say every single mark, you can allocate 1.2 minutes to it. So there's a whole 8-mark question. So 8 times the 1.2 is approximately 10 minutes, because it's like 9.6. So you have plenty of time to work this out. You just don't need to like panic. You don't need to like think that the answer is going to jump into your head. Now, the one thing you can also consider is, like, remember, this is a question from the analytical geometry course. So you do know that I've gone through this already. However, as I'm looking at it now, it's not as though I'm trying to remember what I did. I'm literally just looking at it as a new question, because whatever I did back then, it's not in my head now. I'm not going to keep that information in my head. It's gone.
I hear you.
So the first thing that comes to mind here is, okay, we have this distance given here. It's like 2. To be honest, this distance of 2, we may be thinking to ourselves, why is this even useful? So we may maybe not focus too much on it. This distance here, we don't have anything here. But because from here to there is our radius, and from here to there is also our radius, it seems as though we may have better luck labeling this a certain value. Let's label it X, you see. Like OC, we don't know what it is, so let's label it X. Now, what that does for us is, you see, this is the whole radius. It's just 2 plus X. What we also know, I don't know why I removed that line, but I might as well put it back. What we also know is that this is also the radius. You see, BC is also the radius. So here we can make, let's just write it down. Let OC be equal to X. This is something, if you don't put it out, it's fine. As long as you have it on your sketch there, because your sketches are going to be there on your answer sheet. So OC is equal to X, right? So because of this, BC, let's just say here, not therefore, we're just on a state effect. EC, I'm also writing this out so that it makes sense to you. EC here is equal to BC because they are radii. Radii basically refers to how they're both radius lengths of your circle. They are both the radius of the circle, you see. Because remember, a radius is a line from the center to the edge of a circle. So this is from the center until the edge, center until the edge. So here we can say, therefore, EC is equal to 2 plus X. No. Let me just write them all in one line. Therefore, this is equal to BC, which is also then going to be equal to 2 plus X. So we have a distance of 2 plus X. Now, the fortunate thing is this question is actually not that difficult, because if you look at it nicely, if we can just get a distance, if we can just get X, we'll be able to see, okay, 2 plus the X here, 2. And then if you consider the distance going downwards, with this 2 won't even matter as long as we get X, because as long as we get X, the Y value of C is going to be the distance of X going downwards, you see. And the fortunate thing that we have here is we have the distance BC. It is just 2 plus x. So we have a 2 plus x here, and we have x here. We have 8 over here, and we have a 90-degree angle there. So it's like we can easily get a value of x there because we're dealing with a right angled triangle, of which this right angled triangle has all the sides, has something for each side, you see. There's x here, there's 2 plus x here, and there's 8. So we can easily work out x using Pythagoras.
Can you run back the 2 plus x for me? Why is it 2 plus x?
Yeah. So firstly, do you see that EC is equal to BC?
Yeah.
Because they are both the radius of the circle, from the center to the edge, from the center to the edge. You see it?
Yeah, I see it.
Yes. So if you look at EC, EC is the same as BC. EC is just 2 units here plus x. You see it?
Okay, okay. Okay,
Yeah.
I see it.
So that's why BC is also 2 units plus x. So that's why we labeled this BC as 2 plus x. So there's B here, there's C there, and there's O there. Now, what's useful to us is Pythagoras in this case, because we know that according to Pythagoras theorem, BC squared is equal to OC squared plus BO squared. And then OC here, you can see it's going to be like 8 and square it. BO is going to be x, and then you square it. BC is going to be like 2 plus x, and then you square it. Of which everything here, let's just see what it's going to be. 2 plus x, 2 plus x. 8 squared is like 64. X squared here is just x squared. Here 2 times 2 is a 4. 2 times the x is like 2x. Another 2x. And then x squared there. And then from here you can see we're literally home free because it doesn't look like there's any heavy lifting to do anymore. Here, 4 plus the 4x plus x squared equal to 64 plus x squared. We can take everything to one side, maybe probably to the left or something. Or rather all the numbers to, we could, this x squared here and this x squared, they're gonna cancel each other out because if you take them to one side,
Okay.
these go away.
The signs change.
We're gonna have 64. Yeah. And then minus 4 there, 4x, we can leave it. So here we're gonna have 60 for x over there. Divide both sides by 4. We have a 15 here, and then this is x. So x is equal to 15. So if we look at it nicely, that does look a bit accurate because 15 is bigger than 8. So if x is equal to 15, that kind of automatically gives us the y value of our center. Because if the distance from the origin going downwards is 15, it means that, therefore, the coordinate of C is 0, coordinate minus 15. Does that make sense?
Yes, it makes sense.
Cool, because the value of x is 15.
You're reminded that I never would have thought to
move-
use the Pythagoras theorem. So just like, I'd like to ask, like, under what conditions can I use the Pythagoras theorem? Like if it's a right angle triangle, like.
Yeah. Anytime you see a right angle triangle, you can always use Pythagoras if you need a length of that triangle and you have, enough information. So again, it goes back to, past papers and all that. They keep you reminded of what you have at your disposal. Now, that's one thing I can say. You can use it whenever you want to use it.
Okay, thank you.
Cool beans. So with what is this? With what we have now, you see we have the center and the radius is also in our face now because the radius is BC. Whatever this length is or whatever EC is, it doesn't matter. As long as we have x now, we have the radius. The radius is just x plus 2, which is like 15 plus 2. So we have the center, right? Maybe even label it just for the vibes. the radius. The radius is 15 plus 2, which is like 17. You see, we have the center, we have the radius. It's all nice. So moving on from here, let's see what we can do here. Here we can say therefore x, well, there's no 0 here, so we might as well just leave it. And then plus y. If it's a minus 15 here, you have to put a plus 15.
That's 15. I remember you told me that.
And then this is 17 squared, you see. So can you see all we did was the a is the x value of the center, b is the y value of the center, r is the radius. So you can see this format, if you leave it like this, you'll probably like get 6 marks. But then to get the other 2 to give you 8, you just have to like multiply out your bracket here. So here this one is set, there's nothing to do, so you can just leave it as x squared. Here now, you have y plus 15 twice. So 2 brackets that look like this. So here x squared, y times y, like y squared, y times 15.
Yeah.
And then here also 15 times 15, I think that's 225. I'm saying I think, but I should just verify because, you know, using the calculator is 100%.
Yes, 225.
Great. 17 squared is like 289. And then we can keep checking what we need to get. Okay, so you see we have to put everything on one side, as you can see there. Or rather, let me check nicely. So here it looks as though we don't have anything with the y, x. We don't have anything else with x, right? Which is fine. So we just have x squared here. Y squared, we don't have anything. We don't have any like term. The 15 and the 15, that gives us 30. The 225 minus the 289. 225 minus 289. It's going to be negative 64. So let's just put here negative 64 equal to 0. So here, as you can see, right, there is something here with x. We don't have anything at all. So you could just give it a placeholder of 0, like 0x. No, just to come after this thing here. There is y squared here, and then that, so 30y minus 64 equal to 0. Because if you look at what we're trying to get, the fortunate thing is if you don't have anything with like 0x, it's not like it's wrong. I'm just putting it there so that you can see what would happen or what you actually have, since we don't have anything for this x here, because we have something for the y with the coefficient, but we don't have anything with the x from what we had done. You see, so with us not having anything for the x, you can just replace it with 0 as a placeholder.
Yeah.
That's absolutely a choice. You see, because remember what we're trying to prove looks like this. You see, and this is how you can see everything is matching. There's x squared there, y squared there, something with x. Since we don't have anything else, we just put a 0 there because 0 times x equals to 0 anyways. Here the 30 is for the d there, the negative 64 is for the e, and then you get your 8 marks from that. Cool.
Jeez. Cool.
Yeah. So the one thing I can say about this question